folks. Hope this video finds you well. So in this question here, we're going to set up this object and we're going to draw the planned elevation and find out what it's like when it's cut by the oblique plane. The second thing then is we're going to get a true shape of that cut surface. So that is the question there, and to save time I have this question set up. So what we're going to need to do there are the traces of the oblique plane. We are going to need to look along the horizontal trace. Now even though the horizontal trace goes on to infinity, the portion I have drawn is true length because it's on the horizontal plane. So if we look along this, we'll see an edge view of the oblique plane. Now our x1, y1 is always perpendicular to the line that we're looking at. And what we need to do then is we need to take any random height from here. So we take that height there. Now wherever you take that height, you must bring it up into the auxiliary. So I'll mark off that height with my compass. And that now is a point on the vertical trace. And now what we'll do is we will bring this up, all the points up, Now we know A, B, C and D have a height of 30, so we can mark that off there. We know the top here has a height of 100. Now it's just going to go off my page, so I'm just, if you forgive me, I'm just going to draw that out here on my board. But I can still connect all of these up here to that point. No, they're all running up there. So we can see now where this is cutting. It is cutting, oblique plane is cutting, this is the, we'll relabel them actually. That's corner A, B, C and D here. Now it's cutting corner A right here on the edge of my page. It's cutting B here. It's then cutting, so it is cutting this point here, which are going to be a couple of points left and right here. So there's going to be a point either side there. There's going to be 2 points there. It is cutting the corner C here, and it is cutting D down here. Okay, so what we're going to do is we're going to drop these back into plan and find these points. So this one is on the edge B. This one is on the edge A. Okay, these two guys here, there's going to be 2 points here now. So this is 1 point, the first point we brought down, that's the second point. There's going to be a point there, and there's going to be one over here. And these two guys now are on the corner C, and this guy is on the corner D. So we have 6 points there. And that is the cut shape, what it looks like in plan view. We can do in the rest of our lines heavy now, just to make everything stand out. Now I'm going to label these as well. I'm going to call that 1, 2, 3, 4, 5 and 6, and up there in plan that'll be 1, this guy's 2, we have 6 on the near side and 3, 5 is on the line C, on the corner C, 4 is on the corner D there. Okay, and we get these points in elevation now as well. So that will give me point 3 there. Point 6. There's point 2. There is point 1. And then 5 and 4 there, they're on these corners here. But where exactly do they stop up there? Well, what I can do there is I can measure off their height up here. I can just mark it off there. There's, that's 4, sorry. And 5 is on C, so we'll just measure off his height there. And this is the great thing about labelling, you know, if 1 to 2 to 3 to 4 to 5 to 6 has to go back the same way up here. So 1 to 2, down to 3, down to 4, over to 5, up to 6, and then 6 back up to 1 there. And then I'll just finish out the rest of this guy heavy as well. Now B is in hidden detail, he's at the back there. And then with 5 here and 4 there. So that's the first part of the question finished. That's our plan and our elevation there. And now all we have to do is we have to get the true length or the true surface of this cut shape. So the handiest way there to do that, folks, we have an edge view of the cut surface there. This is our true length line that we looked along. We see it at a point up here. So I'm going to use this hinge line as a hinge line, and this will be my hinge point up here. Okay. And what we're going to do is we're going to knock all these points down onto the ground. Just going off the page there, just fit it. That's all them guys knocked onto the ground there. Now, if my projection lines went up at 60 degrees, they must come down at 60 degrees as well. So run down our lines. And I might have to put a piece of paper in under this now. Bear with me 1 minute, please. Let's tape that on. So them points now are all running down there. I'm just going to shove up this guy a bit so we can see this clearer. And I'll extend down my lines another bit. Now, that's the edge view knocked onto the ground. This is a rebatment. All lines, points are coming down this way now. So all we have to do now is bring these guys out, and they must come out at 90 degrees to your hinge line, because the true surface was there. All we're doing is flopping it over onto the ground. So if we fire the corresponding points, there's there's two points on this line now. There's 3 coming down onto the ground. I'll bring them out. That is 3 found there. That is 0.6 found here. Now they're coming out at 90 degrees, don't forget that. 0.4 coming out there, and I forgot to bring him down. And I'll just keep going with the rest of the points now. 5 coming down. .5, and then my last 2 points, 1 and 2. 2 is on this line here, coming here, and 1 is over here. So follow down the corresponding lines, and where the meet must give you the point. And that, folks, is our true shape found of that cut object. So you'll get a question similar to this. So I hope you found that useful, folks. More videos to come. Take care. Stay safe.